As a DevOps engineer, having a clear understanding of backups, restores, snapshots, and database scaling in the cloud is essential for ensuring data reliability, availability, and performance. Here's a breakdown of each concept with a focus on practical application in cloud environments like AWS, GCP, and Azure. Backups. What it is. A backup is a copy of data stored in a separate location to protect against data loss. Key concepts. 1. Automated backups. Most managed cloud databases, for example, Amazon RDS, Google Cloud SQL, offer automated backups on a schedule. 2. Point-in-time recovery. Allows restoration to any second within a retention period. 3. Retention period. Typically configurable, for example, 7 to 35 days. DevOps considerations. 1. Ensure automated backups are enabled. 2. Verify cross-region backups for disaster recovery, multi-region strategy. 3. Use encryption for backup storage. 4. Automate backup testing to ensure they are restorable. Restores. What it is. The process of recovering data from a backup or snapshot to a working state. Types. 1. Full restore. Recovers the entire database. 2. Point-in-time restore. Restores to a specific timestamp, for example, before corruption. 3. Table-level restore. Some services like DynamoDB support this. DevOps considerations. 1. Know how to restore quickly to meet RTO, recovery time objective. 2. Test restores regularly as part of disaster recovery drills. 3. Document restore procedures in runbooks or incident playbooks. Snapshots. What it is. A snapshot is a read-only, point-in-time image of a volume or database. Uses. On. Quick cloning of environments, for example, staging. 2. Backup of state before deployments or upgrades. 3. Faster than traditional backups, typically stored in object storage, for example, S3. In practice. 1. AWS, EBS snapshots, RDS snapshots. 2. GCP, persistent disk snapshots, Cloud SQL snapshots. 3. Azure, managed disk snapshots. DevOps considerations. 1. Automate snapshot creation before changes, via C/CD or Terraform. 2. Tag snapshots with project/NEM names and timestamps. 3. Manage lifecycle to avoid storage bloat, for example, auto-delete old snapshots. Database scaling. What it is. Increasing a database's capacity to handle more load can be vertical or horizontal. Types of scaling. Vertical scaling, scale up. Increase compute/memory of a single instance. Easy, but with hardware limits. Horizontal scaling, scale out. Add more nodes/instances, for example, sharding or replicas. More complex but supports much higher loads techniques. Read replicas, offload reads, for example, AWS RDS read replicas. Partitioning/sharding. Distribute data across multiple nodes. Caching. Use Redis/Memcached to reduce DB load. Auto-scaling. In serverless DBs or NoSQL, for example, DynamoDB, Cosmos DB. DevOps considerations. Monitor CPU, memory, IOPS, latency to detect scaling needs. Use infrastructure as code, IAC, to provision scalable database infrastructure. Understand connection pool limits and bottlenecks. Use monitoring and alerting, CloudWatch, Stackdriver, etc., for proactive scaling.